So we want to take a look at solving proportions. Okay, so two things we need to take a look at first is what is a ratio and what is a proportion. So a ratio is a comparison of numbers, and we can write it in three main different ways. So we can use a colon, which we say as 4 to 9. We can actually write the word 4 to 9, or we can write it as a fraction 4 over 9. So still can say it as 4 to 9 if you want. This is the one that we're going to be using mainly when we're dealing with proportions. Okay. So a proportion is two ratios set equal to each other, and in this case, we're going to be using fractions to represent our ratios in this objective. We're also going to be making use of the cross product property. So what this says is if A divided by B equals C divided by D, we can multiply on the diagonals. And we can say that A times D is going to equal C times B. And we're going to use that in order to solve our proportions. So let's take a look at some of these proportions. Okay, so anytime we look at these, we mostly just want to start by applying that cross product property. Okay, so multiplying straight across here, we get 24x equals, and then multiplying across here, we get 21 times 8, which is 168. At this point, it's just a normal solving equations. We don't have any fractions. So I'm going to divide both sides by 24. And we find that x equals 7, and we are done. Okay, so we get a little bit more tricky when we start getting polynomials that are bigger than a monomial. So something that has terms, multiple terms linked by addition or subtraction. And we want to treat those always as a group. So my suggestion is anytime you see addition or subtraction in these problems, go ahead and group those terms with parentheses because it's going to come into play later on down the line and be very important. Okay. Actually, it's going to come into play in our next step. So we're going to use the cross product property. Now, when we multiply this, we have to remember that x plus 4 is a quantity. So we're going to have 16 times the quantity, so we use parentheses, x plus 4. So now if you're looking at that, you can see, ooh, we're going to have to distribute. So you don't want to multiply 16 to just the x or just the 4. You have to multiply it to both. All right, next cross product, 9 times 32, we get 288. So a couple different ways to solve this. You could just straight up divide both sides by 16, right? That's multiplication in there. Inverse of multiplication is division. But I think most of you guys are going to want to distribute. That's what I see most often, so that's what I'm going to go ahead and do. So we get 16x plus 64 equals 288. We want to subtract 64 from both sides. We get 16x equals 224, there we go. Divide both sides by 16, and we find that x equals 14. Okay, now, just real quick, before we move on to the next two, you can do a check for these, just like you did back in solving equations. So we're just going to plug 14 in for x, 14 plus 4, all divided by 32, and we're hoping that that equals 9 over 16, right? So what we're going to do is we're just going to kind of simplify that left-hand side. So 14 plus 4 is 18 over 32. And I'm going to reduce that, right? So I can see 18 and 32 are both even. So I know they're both divisible by at least 2. So I get 9 over 16 equals 9 over 16. And that is what we wanted. So we're good to go. We did this correctly. So if you want to check your answers, it's always a good habit to get into. Even if you just do it quickly in the calculator, you don't necessarily have to write out your work like I did. Let's check out two more problems. So for number 3, first thing I'm going to do is I see some binomials. I'm going to group them so that I don't forget that I'm going to have to distribute later on. All right, so I'm going to do my cross product. This is going to be 17 times the quantity, x plus 4, equals, next one, 9 times the quantity, 2x minus 5. Now, one thing I'll point out here is some of you guys might write x plus 4, the quantity x plus 4 times 17 instead of the reverse, and that's fine. What we want to remember is multiplication is commutative, so it doesn't matter which one of these we write first. I find it always easier to write the constant term in front instead of anything with a variable, and that's more standard as well. Okay, so let's go ahead and distribute. So we're going to have 17x plus 68 equals 18x minus 45. I'm just going to go ahead and move my variables to the left-hand side because that's sort of where we want them when we end this problem anyway. So I'm going to subtract 18 from both sides. We're going to get negative x, or negative 1x plus 68 equals negative 45. That's not the only way to do that. It just depends on how you like to do things. All right, continuing to solve, subtracting 68 from both sides. And then I have to get rid of that negative. So remember, that's really a negative 1. So I'm just going to divide both sides by negative 1 real quick to get that x equals 113. All right. So last one. The trick that I use here is I want to remember that any integer can always be written as a fraction. So 11 is an integer. Can always be written as a fraction by just putting it over 1. So before, we didn't have a fraction equal to a fraction, but once I put it over 1, now I have a fraction equal to a fraction, and I can use the cross product property a little bit more easily. So first multiplication gives us 11x. Second one gives me 33. Divide both sides by 11, and we get x equals 3.